Hi, this is Miss Webb. I'm trying a new software package, so we'll see how this works. I'm not sure, not real confident, but this is my second try. Okay, I'm going to talk to you about graphing linear inequality systems. And I'm going to break this into graphing the systems and into writing the systems because as a class we really struggled with this. So the first one, we're just going to talk about graphing linear inequality systems. Okay, you actually follow the same steps for a system of inequalities that you do for one inequality. The only difference is now you're looking for overlaps. Where does the shading overlap? Okay, because remember, when you're talking about a system, it has to be true for both equations, so it has to be in the part that's overlapped. Let me get my other pen out here. Okay. So the big deal is the overlap. Okay, so let's get started here. I'm going to give you the steps. First, when you look at it, you need to decide if the line is solid or dashed. Okay, if it's less than or greater than, it's a dashed line. That means it's not included. If it's less than or equal to or greater than or equal to, it's a solid line. That means it's included. You're going to graph the line. You're going to you want to treat the inequality as an equal sign. Don't worry anything about the inequality till the very end. After you graph the line as if it was an equal sign, you decide whether it's dashed or solid. Then you're going to check any point, and this is the key part, with the original equation on either side of the line to determine which region to shade. So if you check it and it's true, then you get to shade that side. If you check a point and it's not true, then you better shade the other side. But let's try one. Okay, so here are my two inequalities. Notice it's just line number 1 and line number 2, but if I want to solve the system of inequalities, then I'm going to start with line number 1. Y is greater than 2x plus 1. Notice it's in slope-intercept form, which I'm really happy with because I know how to graph it if it's in slope-intercept form. But I'm going to find out, okay, it is a greater than sign, so I know it's going to be a dashed line. A dashed line. Okay, I'm going to graph the line, and I know I have the point when x is 0, y is 1. I get that from using my eyes right there. And I know I have a slope by looking at that coefficient there, and it's 2 over 1. Now that means I'm going to go up 2 and to the right 1 because they're both positive. So I'm going to come over here and I'm going to say 0, 1. Actually, you know what I'll do is I'll go get this guy. Well, let me try this first. Okay, 0, 1 is right there. And then I have my slope of up to 1, 2 over 1. Okay. Now what I am going to do, because I know it's a dashed line, I'm going to go get my dashed line here. And when I come to draw it, I am going to make sure it goes through those 2 points right there, and it's dashed. Okay? Okay, now I have to decide what side to shade, because it's an inequality. It's not just, well, actually it doesn't pick anything on the line because it's dashed, but I need to know if I need to shade this region or this region over here. So I'm going to check a point. Now, I can check any point I want. I'm randomly checking a point. Now, I always like to pick, I need to be on my pen. I always like to pick 0, 0 if I can, because that's easy. Also, it cannot be a point on, you don't ever want to pick a point on that line. So the important thing is when I check the point, I go back to the original equation up here. That point is 0, 0. So y is 0, greater than 2x is 0 plus 1. So that's 0 is greater than, that's 0 plus 1. I have 0 greater than 1. Is that true? No. So I cannot shade this region. I'm going to have to shade the other side. And I'm going to come over here. And the solution's got to be over here. Look, I'm going to go, oh, if that extended that line out, it's this entire region over here. That's the first line. Okay. Let's look at the second one. The second one, okay, is y is less than negative 1/2 x minus 1. Okay, is that going to be a dashed or solid line? It's going to be dashed. Okay, I need to be able to graph that line. This is in slope-intercept form. You should recognize I have a point 0, negative 1. I do that by looking at right here. If I set x equal to 0, then y is going to be negative 1. And I have the slope of negative 1/2. Does it matter whether I put the negative on top or on bottom? No. It can't be on top and on bottom though, because that would be a negative over negative, which is positive. Okay, so I'm going to say I'm going to go down 1, but I'm still going to go right 2, because that 2 is positive. So I'm going to come over here, I'm going to say 0.0, when x is 0, y is a negative 1. And my slope, I'm going to go down 1 to the right 2. Down 1 to the right 2. I could also, instead of going down 1 to the right 2, I could go up 1 to the left 2. Up 1 to the left 2. Okay, now I'm going to go get my line here. And I know it's the dashed line. And let me make sure I got it. Okay, I'm going to make sure. Oh, that's not a very good one. Let's try a different one. I have no idea what that is. I don't know what that's doing. I'm going to go back to my pen. I'm just going to extend it out there, but it's dashed. Okay, now, when I look at this one, I need to check a point. I can still check the point 0, 0. I need to know whether to shade this whole area or this area down there. So I'm going to go check 0, 0. So I say 0, I'm putting it into the original, is less than negative 1/2 times 0 minus 1. 0 less than negative 1. Is 0 less than negative 1? Is that true? Is negative 1 greater than 0? No, it's not. So I know this is not part of the solution. So I'm going to come get my highlighter and I'm going to go with this green guy. So I know that this is not part of the solution, so it's got to be down here. Everything down here. Yeah, it didn't do what I was hoping it would do. Okay. Now I need to find the solution. Where does the green and the yellow overlap? So let's see if it'll let me do it in a darker color. Purple. Okay, so I'm going to go, it's got to be on this side of that line, but underneath that one. It's going to be this area right here. That's where the yellow and the green overlap. Okay, let me see if I have another example. Okay, so here's my second example, and I wanted to throw in a special case and also something in standard form. So the very first line is y is greater than 2. Y is greater than 2. Now if I tried to figure the slope out or do You can't do that. This is a special case. Where is y? Say it's y is always equal to 2. Well, there's 2. That's when y is equal to 2. Is y equal to 2 right here? Yeah. Is y equal to 2 right here? Yes. Doesn't matter what x is, y is always equal to 2. I put a dashed because it's a greater than sign. Okay, and since this is a special case, I just graph it. If this line was x greater than 2, it would be a vertical line. Okay, now I need to check a point. Look, I have a 0 right here. I really like that. Let's go put 0, 0 in there. Is 0 greater than 2? No, it's not true. So, let's go get my yellow. This is not part of the solution. It must be up here. Because the point I tested does not make the inequality true. Okay, let's try another one. Okay, let's try the second line of the system. Now this one is not in slope-intercept form. And you have a choice. You can put it in slope-intercept form, or you could go find the x and y intercept. I think it would be easier just to put it in slope-intercept form. Whatever I do to one side, I do to the other side. And I end up with y equals that negative 2x plus 4. To me, that would be the easiest way to do it. Okay. And sorry, this should have been a greater than. Okay. So my first step, it's a greater than or equal to, so it's going to be a solid. If I want to go graph this line, I put it in slope-intercept form. I have a point, 0, 4. I have a slope, negative 2 over 1, which means down 2 and right 1. So I'm going to come over here. I'm going to find the point 0, 4. And then I'm going to go down to right 1. Down to right 1. It's a solid line because it's a greater than or equal to. I don't know what makes it do that. I don't like it though. Well, let's try it again. I'm going to try making it, let's see, maybe it won't let me do it. Let me try a solid line again. Let's see if it'll let me do it. That looks good to me. If I could make this a little bit longer, I would. Okay. Okay, so I have graphed the line. Now I need to check a point. You know, I'm going to check 0, 0 again. So, but this is where it's important. You need to check it in the original equation. Okay. Notice how I modified it and put slope-intercept form? Don't go there. Go back into the original and check 0, 0. Why? Because we have that special rule that when you're working with inequalities, if you divide or multiply by negative, you have to switch the signs. But I don't have to worry about that or even think about it if I just go up here and whatever point I select, if I make sure I look at it, let me get my pen back, I look at it in the original equation. So I would put 2 times 0 plus 0, is that greater than or equal to 4? Is 0 greater than or equal to 4? Is that true? No. So I know this is not part of the solution. So what I do know, let's do a green. This has got to be the solution to that inequality. Okay. Okay, my last step though is to say, okay, where's the overlap? And the overlap, if I come, I'll do it in a dark purple. Dark purple. The overlap is going to be this area right here. Okay, let's see if I have I think that's the last one I have, but let me double check. That's it. Okay, your assignment is 4 of them where you're trying to graph the inequalities and find the solution. Good luck.